Hey guys, Cracking the Cryptic just released a video today that says, please try this Sudoku, you won't regret it. So, I've not watched the video, I've not played this Sudoku, but I'm going to, let's do it. I don't know anything about this, I just saw the title and was like, alright, let's play this Sudoku. So, normal Sudoku rules apply, which means we have to put the digits 1 to 9 in every row, column, and marked 3x3 box. The 3x3 box borders divide each blue line into segments. Along an individual line, each of those segments must have the same sum. Okay, so these are region sum lines. So basically, like right here, on this line, there is this box border that is splitting this into two segments. We have this segment and this segment. And so that means that these have to equal the same sum. So if this is 6, then these two digits have to add up to 6 pretty much. And then if these three, so these are divided by this spot right here, if these three add up to 7, then these two in this segment also have to add up to 7. And then it's the same for like up here. If these add up to 10, then these three have to add up to 10. These 4 have to add up to 10, these 3, and these 2. Okay? Right. Now then, let's get started. So, the first thing that I notice is that these 4, they all have to be different digits. So that means the minimum they can be is 1, 2, 3, and 4, and those add up to 10. So the minimum that this can be is 10. And then up here, we've got 2 digits. The maximum that can be is 9 and 8, which adds up to 17. So the minimum is 10 and the maximum is 17. What is happening? That's so weird. What the freak? What? Okay, sorry about that. I had some technical difficulties. Right. So there's a minimum of 4 here. There's a minimum of 10 here and a maximum of 17 here. Right here, there's a minimum. There's a minimum of 10, and over here, there is a minimum of 24. It's 9, 8, 7. So this digit is gonna be grouped with a minimum of 6 over here. The minimum the other 3 could be is 6. So it's going to have to add to that 6 and be less than 17. So if it's 9, this is 6, so that's 15. That's fine. Something I do find interesting over here. This is like this equals the same as this, which equals the same as this. So whatever the sum of this is, let's say it's x. In this column, we have 3x. And the same thing is going on right here. we have 3x. Actually, never mind. Ignore that. This is connected. This is all 1. So this is this minus this. That's when what? This is this. This is this minus this. Sorry, I've not really done region sumlines before. Is this... Hold on, is this set theory? I think it might be set theory. I've not really done set theory before either. But, yeah. I think it's set theory. How do I do that? So, let's say this column and this column are purple. Each of these columns have the digits 1 to 9. And there's a secret of Sudoku that was told to me by a very special somebody, and I'm going to share that secret with you. The digits the digits 1 to 9 sum to 45. If you add them all together, the triangular number for 9 is 45. So the sum of all of these digits right here is 45. And the same is said over here. That's also 45. Now, if we take this row and this row, it's the same thing. This is 45 and this is 45. Now what you can do is say, so basically orange and purple are equal right now. They're both 45 twice. They're both 90 in total. So that they're equal. And if you were to remove this spot, you'd be removing it from both purple and orange. You'd be subtracting the same digit from both categories. So it's 90 minus x for both. So it will stay the same. It would stay the same. They'd both still be equal. Because you're subtracting the same thing from both of them. They stay equal. So you can do that in all of the sections where they see each other. So right here, orange, olive orange has the same sum as olive purple. Now, what does that mean? I'm not sure. So what we now know is this and this are equal to this and this. We also know that this is equal to this, which is equal to this, which is equal to this, which is equal to this. Okay. So right, so this right here, this is 1, 2, 3, 4, 5. This is 5x. And this right here, this is 1, 2, 3, 4, 5, 6? I feel like I did that wrong. I did do that wrong. This is 1, 2, 3, 4, 5. So this is 5y. See, we know that all of purple is equal to all of orange, but we don't know if this orange is still equal to this orange, I don't think. And we don't know if this purple is still equal to this purple. Because although we removed this digit from both orange and purple, that just removed it from the sum of purple. It wasn't removed from both this side of purple and this side of purple. I guess, for instance, if that were the case, this digit and this digit would have to be the same, and this digit and this digit would have to be the same. How do I explain that? Hold on. Because this right here, we're removing this digit from this row of orange and this row of purple. So it removes it from orange and purple. So we know that orange and purple are equal. But that digit was not necessarily removed from this side of purple and this side of purple, if that makes sense. But for that to work, for this purple and this purple to be equal, as well as this orange and this orange to be equal, two of the corners, there have to be two pairs of corners that are the same digit, and the only way for that to work is if it's the opposite corners. For instance, for that to work, this would need a digit that is the same as itself, and it can't then go with that corner or that corner because it sees those corners. So it would have to be that one. And oh my gosh, the cats are causing a ruckus right now. Oh my goodness. 1 second. Okay, so as I was saying, there has to be two pairs of digits that are the same. So this one would need another corner, another one of the ones that was removed, to be the same digit as itself. And it can't be that corner or that corner because it sees both of those corners. It's in the same column as this one and the same row as this one. So the only option left is this one. And then we need another set of digits that are the same. And so the only two options left are those two. So in that world, these would be the same. And these would be the same. But we don't know if they have to be equal. We don't know if they have to be equal or not. It's interesting, since these have to be the same. So it's like this, the sum of these is the same as the sum of these. Which would mean, and this is the same sum as this. So if we take the sum and subtract yellow from both sides, we would get the same remaining two. So this would have the same sum as this. Which is interesting, I guess. Oh, wait, here's a point. Maybe? No, that's not a point. Sorry, I was going to ask if 9 can ever appear on the region sum line, but that was not really a point because yes, it can. the maximum for the sum is 9. Sorry, the maximum of the sum is 17. So 9 will be able to appear on anywhere on the line, I think. I do know that 9 can't appear on here because the maximum one digit can be is 9. So if it's on here, it would be 9 plus something else, which would make the sum higher than 9. So 9 can't be here or here, nor can it be here or here for the same reasons. Nor here or here or here or here. You know, I have a feeling that I have a feeling that the greens are going to be 9. But I don't know. I guess something, if there is a 9 on here, I guess, yeah, if there's a 9 anywhere that's not on the 2, then it is blocking 9 from creating 17. Because if there's a 9 here, then there can't be a 9 on here to make the 17. And if there's a 9 here, then there can't be a 9 on here to make the 17. So, if there's a 9 here, that then makes the maximum that this can be 7 plus 8, which is 15. Okay, so I think that works here. We could have a 1 and a 5 go with it, for instance. But if we put it here, that's 9. It makes it so the maximum is 15. We add 1, 2, and 3. And that would be 15. Interesting. So, if there is a 9 in this area, then the sum of the region is 15. Okay. So, this has me wondering, if purple is equal to purple and orange is equal to orange, then this region sum, and this whole thing is equal to this. So this region sum line minus this digit twice is equal to this region sum line. That's weird. The sum of this region sum line minus 2 yellow is the sum of this region sum line in the event that these 2 oranges are equal and these 2 purples are equal. We still don't know if they are or not. I can't figure out how to prove one way or the other. If this is a 9, this is a 7 and an 8. These are 1, 2, and 3. And these have to sum to 15. And they can't have 7, 8, or 9. I think that's possible. Is it? They have to sum to 15. We can do 4, 5, and 6. Yeah. So this would be 7, 8. This would be 4, 5, and 6. One of these would be 9, and the other 3 would be 1, 2, and 3. And that would leave 1 and 2. I think. No, because this would be 1, 2, or 3. Oh, so these would be the other 2 of 1, 2, and 3. Which would make these also be the other 2 of 1, 2, and 3. Okay. Is there a way for me to prove that they're equal? So I remove this from both purple and orange. And I also remove this. See, by removing this from both purple and orange, I'm removing it from the total of 90 for both of them, and I'm removing it from the total of 45 from this column and this row. But I'm not removing it from the total of 45 from this column or this row. So in order for them to be equal, I have to remove it from this column and this row, and in order to do that, this digit would have to be the same as this digit. And the same goes for these. Okay, let's ignore what we did with set for a second and move over. Wrong one. Instead, let's just focus on this region sum. Yeah. So this column, the sum is 45, and this column, the sum is 45. And if we remove this digit from both of them, we're subtracting the same digit from both of them, so they remain equal. Which means purple is equal to orange right here. And we know that this is 2x of the region sum. This is the same as this, so this altogether is 2x. And we know that these two are also the same. They are also 2x. So this and this are both 2x, they're the same, which means these, adding these is also the same. That means that this has the same sum as this, as well as this whole thing having the same sum as each of these. So that does give us a bit more information. This and this have the same sum. What does that tell us? So basically, that means that this is half of the sum of this is half of the sum of this. This right here, yes, this right here is half of the sum, which means that the sum is even. Yes. This, so let's say the sum is x, and this right here is y. 2y equals x, which means x is a multiple of 2. It's even. That might be useful. In a weird way, it makes this right here, the sum of this right here is 2.5x. Okay. So we know that the sum is even. This is 2x. And this is half of x. So let's say if we make it the minimum, the minimum being 10, that would make this 10 and this 10, making 20, and this would be 5. That would be 25 right here. And this would have to fill in the rest. This would have to add up to the sum of the digits 1 to 9. And in order to do that, it would have to be the digit 20. And I don't think we can do that. I don't think we could put the digit 20 in a Sudoku puzzle. So we know that it's not 10. We also know that it's not odd. Okay, so the max it can be is 24. So if this is 24... Wait, what? Yeah, no, that immediately doesn't work. If this is 24 and this is 24, that's 48. And then we're already above 45. So it's not 24. I need to find the actual maximum. Or yeah. What we have is the minimum this collection of digits can be. That's 1, 2, 3, 4, 5, 6. The triangular number for 6 is 21. And it can't be 21 because it has to be 2x. This is x, this is x. It has to be 2x, which means it's a multiple of 2, which means it's even. So 22. So if we and it can't be 22 because if it's 22, then half of it would be 11, and we know that the sum we know that, yeah, so half of it would be 11. That would make the region sum 11, and we know that the region sum is 2y, which means it's even, so it can't be 22. So 24, okay, yeah, 24 might work, but it doesn't. Wait, sorry, no. If this whole collection is 24, that would mean that the region sum is 12, which would mean that this is equal to 6. So that would be 24 plus 6. That's 30. That would make this whole total 30. And we know that the row has to be 45, so we would have to add 15 right there. So I think what I'm trying to say is this has a maximum of 9. So this has a minimum of 36. Yeah, this has a minimum of 36. I really don't want to go through each option and individually prove it wrong, but I might have to. If this is 9, then this is 36 right here. That means that it'd be 2.5 x. You know, if this was x instead of half of x, I could just divide 36 by 3 and know that the sum is 12, but this is half of x, and so I'm not sure what math I should do to figure out what x is right here. Okay, what did I just do? I just did 24, and then when we did 24, each of these became 12, and this became 6. So 24 plus 6, that was 30. And the minimum is 36. So I guess let's just go up to, can't be 26 because 13 is odd. 28. So if we say this is 28, that would make this 14 and this 7. So 28 plus 7 would be 35. Right? Yeah, 35, which would mean this is 8. So I think that works. This is 8, so the sum would be 12. I mean, not 12, 14. Okay, if this is 1, let's see. It can't. Can it be? Wait. No, I guess that's fine. Yeah, I guess that's fine. If this is 1, then this is 44. So it has a maximum of 44. That's interesting. I'll keep that in mind, I guess. So let's move on to 16. These would be 32. This would be 16. So this would be 8. So this would be 40. Making this 5. Let me just double check that. This would be 16, 32, and then half of 16 is 8. 32 plus 8 is 40. We need to make it 45, so we add 5. Okay. 18. This would be 18, and this would be 18, making 36. And then this would be 9, making 45. Wait. If this is this is 18. This becomes 36. You add 9. That's 45. So that can't work. So are the only options 8 and 5? It's a 5 or an 8. And then the sum of this would be 14 or 16. Okay. So the sum of this would be 7 or 8. Wait. Let me just double check. This is 14, this is 14. This is 24. We got 7. 24 plus 7 is... This is 14. This is 14. Wait. No, this is 12. This is 12. This is 12. This whole thing is 24. We add 6. That's 30. Okay, yeah, we know that doesn't work. This is 14. This is 14. This whole thing is 28. We add 7. It makes 35. Then we add 10. So 14 doesn't work. This is 16. This is 16. This is 32. We add 8. 32 plus 8 is 40. So you then add 5. Okay, this is 18, this is 18. So this is 36. $36 plus 9. Did I make a mistake somewhere? Why? +12 plus 6 is 30. 14 plus 14 plus 7. 35. $16 plus 16 plus 8 is 40. Which would add a 5. Why would this be 8? If this is 8, then this is... Okay, 18 plus 18 plus 9. That's too high. Did I make a mistake on the 14? Like, where did I get this 8 from? 45 minus 8 is... yeah, 37. So for this to equal 37, what did I do? 7? 14. No. 28 plus 7 is 35. So this would have to be a 10. Did I say it'd be 37 instead of 35? I don't think there's a way to get to 37. Because if we go from 14 to 16, then it becomes 32 plus 8, which is 40. There is no $37. I think it has to be 5. I don't know why I put an 8 there earlier. So this I'm claiming is 5. And in addition to that, I'm claiming that the sum of all of these segments is 14. And the sum of these two segments is 7. So you could say this equals 14. That at the 5, that's 19. So we can figure out the sum of this. We just subtract 19 from 45. 45 minus 19 would be 26. So we know that this right here is equal to 26. So we know that this is below 26. So like if it were 987, what minimum is that? 24. So if this is its maximum, and this is a 2, its minimum is 6. And that would make this a 20. That doesn't work. I have just realized. Never mind, I have not just realized. No, that assumption would assume well, I guess maybe I can expand it by going back to what we did before. Remove these digits. If we know what these digits are, we can determine what this is. Okay. I am over an hour in, and I have 1 digit. That is awesome. That's equal to 7. The options for that are 1, 6, 2, 5, and 3, 4. I can't use 5. Oh, yeah, so I know what these digits are. Because it can't be 2, 5, because 5 is taken. So it's either 1, 6, or 3, 4. So one of them is going to take the 1, 6, and the other is going to take the 3, 4. So then I can fill in these digits, which are the rest, which are 2, 7, 8, and 9. If this is a 2, then this is 24. If this is a 7, then this is 19. If this is an 8, then this is 20, right? Hold on, if this is a 7, then this is 19. If this is an 8, then this is 16. No. Yeah, if this is, I don't know where I was going there. If this is a 8, if this is a 2, then this is a 24. If this is a 7, then this is a 19. If this is an 8, then this is an 18. And if this is a 9, then this is an 8. It's 17. Cool. I don't think that tells us all that much. Wait. So we know that this and this are equal. I don't know where I was going there. Oh, I do know where I was going there. I was going to try to use that to prove that these are the same digit. But I can't do that. thought I could, but I can't. Something we do know, we know that 9 is over here somewhere. And 9 is going to have to go with something that adds to 5. Which is going to be 9 is going to go with 2, 3, or 1, 4. Here's an interesting point. If this is so 9's going to be in one of these segments, and if it is in one of these segments, it goes with 2, 3, or 1, 4. If 9 goes with 1, 4, then that knocks 1 and 4 out of these, meaning we're just left with 3 and 6. And 3 and 6 adds up to 9, not 7. So it basically, putting a 1, 4 in here breaks both possibilities for this to add up to 7 that we have available. So wherever the 9 is in here, the 9 is going to have to go with a 2 and a 3. Right? But if it goes with a 2 or a 3, or a 2 and a 3, that would knock 3 out of here. Meaning that this is not 3, 4, it's 1, 6. But that doesn't work because there's also going to be a 9 in this column, which will also have to go with digits adding up to 5. Those options for the digits adding up to 5 will also be 1, 4 or 2, 3. And if it's 1, 4, it will also break this, meaning it can't be 1, 4, so the 9 would have to go with 2, 3, meaning this can't have a 3, meaning this would be 1, 6. These would both have to be 1, 6. What? That doesn't make any sense. Hold on. No, that doesn't work. Hold on. I made a mistake. I don't think that can be 5. Let's go back. Let's ignore this. I still think I'm right about this being half of this, because the sum of this is the same as the sum of this, and the sum of this is the same as the sum of this, and the sum of this, and the sum of this. So this is 2x, and this is also 2x. Yes. And we then add, so the sum will be the same as the sum, meaning we have to add the same sum to both of them to get to the entire sum for it to be the same. So these are the same sum, and since these are the same sum, and adding them together makes this sum, this is half of this, as well as this being half of this, and this being half of this. So if this is y, 2y equals x, think we're right about all of that. But what we did to get there, but what we did after that was we said this is 14. And if this is 14, and this is 14, this is 28, and this is 7. 14 plus 7 is 28 plus 7 is 35. That's where I went wrong. It was the wrong one. It was 16, wasn't it? This is 16, and this is 16. This is 8. And this is 32, so the whole thing is 40, so this is 5. So the sum of this is 16, and the sum of this is 8. Okay, and then 8, this can be 2, 6. Can't be 3, 5. It can't be 4. Oh, it could be 1, 7, 2, 6. It can't be 3, 5 because the 3, 5's there, and it can't be double 4 because you'd have 2 4s in the same box. So it is 1, 7 or 2, 6. So we know that these are from 1, 2, 7, and 6. And so we now know that these are from 3, 4, 8, and 9. Cool. This must equal 16. This must equal 16. And somewhere on here, let's disprove it. Somewhere on here, this will have a 9. And if it has a 9, it will have to go with something that adds up to 7. So there's options for that are 1, 6 or 3, 4. And that would break this right here. And the same thing would happen on both sides. Which means the 9. Oh, it doesn't break. It doesn't break. Okay. So there's going to be a 9 over here somewhere. It has to go something that adds up to 7. And it's either 1, 6 or 3, 4. It cannot be 1, 6 because... Wait, yes it can. What am I talking about? Wait, no it can't. No it can't. It cannot be 1, 6 because it would break both opportunities for this to add up to 8. So, there's a 9 over here somewhere, and it's not paired with 1 and 6, so it has to be paired with 3 and 4. That doesn't break this time because neither of those digits knock any digits out of here. So there's 9 over here that is paired with a 3 and a 4. And we don't know which segment that happens in, but we do know that it happens both on the row and on the column, because the logic works the same both ways. So that's something. So after we have the 9, the 3, and the 4, the other one, whichever it is going to have 8, and then the other 2 digits that we didn't use to add up to 8 here. Okay. if this is 1, 7 adding up to 8, then one of these boxes is 9, 3, 4, and the other one is 8, 2, 6. And since this would be 1, 7, it would make this 2, 6. So one of them would be 9, 3, 4, and the other would be 8, 1, 7. I don't think we can really expand from there. The minimum that this can be is 15 now. And the maximum that this can be is 17. So I think what we're saying, if this has this can't have a 9 and an 8 on it. If it has a 9 and an 8, then that equals. It can't have both. It can't have 9 and 8, because that would add up to 17 plus the third digit, which would make it so this cannot equal that, because the maximum it can have is 9 and 8, which is 17. So one of 9 and 8 will be on here, and the other will not. We can't have both, which means this digit right here is a 9 or an 8. So that means we either have 9, 3, 4 or 8, 3, 4, which are, let me guess, they're 15 and 17. Are they? This is 7, that's 15, they're 15 and 16, so this isn't even 17. These are 15 or 16. That's cool. We don't know which one they are. If it's 15, then this is either 6, 9 or 7, 8. And if it's 16, then the only option is 7, 9. Can we even do that? If this is 16, all of the 2 segments have to add up to, or sorry, if this is 16, then all of these segments have to have 7 and 9. So let's do that. Let's imagine that. Let's say this is a 9, this is a 7. That would mean that can't work. We would have 9 and 7 there, and then this wouldn't be able to be a 9 or a 7. So that can't work. It is 15. Meaning this can't have a 9, meaning that this is a 9. And so now the options for these are between 6, 9 and 7, 8. So I guess we can write those in. 6, 9, and 7, 8. I'm doing the wrong kind of numbers. And since this can't be a 9, that means this can't be a 6. And since this can't be a 9, that means this can't be a 6. Neaterito. If this is an 8, then this is an 8. So that won't be able to be an 8. And that won't be able to be a 7. But that would be a 7. If this is 6, 9, then this is 7 or 8. If this is 7 or 8, if this is 7, 8, then this is 6, 9. So I think that tells us that these two segments use the same digits, because this has to be different than this, and this is in the same segment as this. Yeah, so basically this segment has to be different than this segment, because this segment would break it, and this segment also has to be different from this segment because it would break it. And since there's only 2 options, and this is different from both of these, that means that both of these are the same one. So that's something, maybe? So I guess that also means if this is an 8, then this is an 8, and this is an 8. That would make this a 7, and this is 7. And this would be a 6, 9. But if this is a 9, then this is a 6, and this is 9, and this is a 6. I don't think we're really getting anywhere with that. But I guess something I can do is, I know that this is 15, and I know that this is 16, so I know altogether that they're 31. So the rest right here will be 14, right? No. This is 15 and 16. Altogether that makes 31. The rest will be 14. I was right the first time. Okay. I don't know if that helps us. Also, since these are equal and these are equal, we know that the logic is the same, and this is also 14. These guys are interesting. This is equal, and this is equal. This is the same as that, and this is the same as that. So essentially, this is the same as this. And altogether, this is the same as this. Meaning what's left is this is the same as this. We also know that this is 14. We know that these are the same, and that these actually, I'm gonna I'm just gonna do that. That makes it easier to see. I'm not gonna make this the same color. These are the same. This digit. Like this right here is not necessarily 14, and that's the thing. Or is it? This and this are the same. Oh, something we do know is that 5 appears in both of these boxes, because it has to be in here. So 5 is part of the sum of 14, so the rest sums to 9, but that could be any 3 digits to sum to 9. We do know that this sum is the same as this sum. That's another very interesting thing. I'm going to mark that out. Those all have this, all of the green have the same sum. It's making me want to think that these digits are the same. But this digit could go anywhere. I got it. These sums are the same, and these sums are the same. Which means if we subtract this sum, this sum by this sum, we get this digit. And if we subtract this sum by this sum, we get this digit, which means they are the same digit. Okay, so these digits are the same. And since these are the same, oh my goodness, I didn't even see this sooner. There's so many digits that are the same one. Okay. I need a new color, black. The special digit is black. These digits are the same. And okay. Oh my goodness. Okay. I'm pretty sure I can make that keep going right here. But I'm not sure. Because this sum isn't necessarily 14. But we know that this sum is the same as this sum. Yeah. And we know that this sum is the same as this sum. And And we know that this sum is the same as this sum. And we know that this is the same as this. I can't prove that this digit goes there. You know, yeah, this whole board is very symmetrical along this diagonal. Except for right there. So I predict that that's going to be what disambiguates everything. If we knew that this was the same as this, or if this was the same as this, we would know that this and this are the same digit, but we don't know that. Something interesting I just saw is that this has the same sum as this, and this has the same sum as this. So that means that this has the same sum as this and this. And the same logic works up here as well. I don't know if that's helpful to us at all, but it's something. This is so confusing because my brain is wanting to say that this has the same sum as this, but that is not necessarily true because these do not have to have the same sum. It's just these have to have the same sum as this and this. That does not mean that they have the same sum as. Does that mean that these have the same sum as each other? Hold on. Let's make this orange and this purple. We can ignore this green for right now. If we remove this digit, this and this have the same sum, and then this and this have the same sum. That's not as helpful to us as I thought it would be. If I remove this, it means the sum of this. Never mind. It means the sum of this and this are the same. It also means that the sum of all of orange and all of purple are the same. So all of this it means that this and this are the same. They have the same sum. And I happen to know the sum of this is 40. So that means that the sum of this is 40. Which means that this is a 5. Wait, No. No, oh my goodness, I thought I was so I was so proud of myself for a second there. No. Well, if this is the same as this, and all of this is the same, so this orange is the same as this purple, and all orange is the same as all purple. Ignoring the other weird stuff. This orange is the same as this purple, and all orange is the same as all purple. Actually, by removing that, we know that this and this are the same. These are the same as each other. And all of purple is the same as all of orange. So if these are the same as each other, you subtract all of these, you are left with the rest. So the rest of the orange will be the same as the rest of the purple, meaning that this is in fact the same as this. Okay. We did it. I guess we can try and work out what the region for this is. If it's 14, then this is 24. We had 7. Sorry, no. This is 28. We had 7. We get 35. Plus 5 is 40. That would make this 5, so it can't be 14. If it's 12, then these are 24. We had 6. That's 30. This is 5. We would have to add 10. You're right, yeah. We should go up, not down. Okay, if this is 18, this is 36 plus 9. Hold on. Let's go back to 12. If this is 12, this is 24. Plus 6 is 30. If we then add this, then all of this is 35. And we have to get to 45 right there. And the only way to do that would be to add 10. So it can't be 12. If this is 10, this is 20, this is 25. What? If this is 20, and this is 40. Okay, let's try 16. It's 16. This is 32. This is 40. This is 45. That's 0. This is 14. This is 28. This is 35. This is 40. Making that 5. This is 12. This is 24. This is 30. This is 35. it jumps from 0 to 5 to 10 that you have to put here. And none of those work, and there's nothing in the middle. Okay. I think I know where I went wrong earlier. I said that if you remove all of these digits, then the remaining ones would be equal because these are equal and these are equal, and these contain all of the same digits. But this digit is in purple down here, so, and you're removing it. It's also being removed from purple up here, so you're removing this digit twice. As well as this one. And unless these digits do happen to be equal, that does not mean that these are equal. So this is not necessarily a 5. Something that is interesting, olive purple is equal to olive orange, and this purple is equal to this orange. So if we subtract this orange and purple, not removing something twice this time, that then means that this is equal to this, which does in fact mean that these are the same. But that's not true, because this is not necessarily equal to this. But we're back where we started, where we don't know if this is equal to this, or if this is equal to this, or if this is equal to this, or if this is equal to this. And I think that just might be impossible to be the case. Because if this is equal to this, it means adding this. It means this is equal to this. And if this is equal to this, that means this is 40, which means there's a 5 right here. And as we realized earlier, if we try putting a 5 here, then trying to do this would result in this either having to be a 0, a 5, or a 10. And none of those can go there. So, I think that means that this is not equal to this, which means this is not equal to this. Which is a bummer. So, where were we? This and this are equal to this and this. That's nice. These are equal to these. This is equal to this. This is equal to 8. All of this is equal to 16. These are equal to 16. These are equal to 16. These are equal to these. These are equal to these, which... Wait, these are equal to these, which are equal to these. We've got a minimum of 6 and a maximum of 17. Not helpful. Same here, minimum of 6, maximum of 17. So we have a minimum of 3 and maximum of 9. Right. So... those have the same sum, as I said before. And the sum is a minimum of 10 and a maximum of 17, just like this. 9 appears in one of these cells, as well as one of those cells. 9 is going to be in this section somewhere. This digit is... what was this? 7, 15. So this is 15. So this whole thing is 16 or more. This is 16 or more. We know this is 15. If that's 9, it makes this whole thing... Hold on. Why did I say that this was equal to this? Because this is equal to this. And this is equal to this. I don't know if that's true. I know that it's its own section. I'm gonna get rid of a lot of this coloring because I don't know if it's true. I know that these are the same as these. They have the same sum. And that these have the same sum as these. But this is 14 in total, and this is 14 in total. But these could have a different total than these. I don't see why they would be the same. These have the same sum. And these are both 14. Great, why not? But yeah, these areas can make 14 in different ways. So this isn't necessarily 14. These three areas are the same. I'm going to replace yellow with green here. I'm going to replace these with red. So it has the same sum. I'm going to do the same color. But I'll leave these the way they are because that would get confusing. So let's take away the red. And instead of blue here, we can do, or this can be yellow. Why are you like that? And these, let me take away the blue. These can both be black. While we're at it, we can make all of these light gray, and these no, that looks too, these purple. This is crazy. These can be dark blue. And these can be dark green. Oh, and these should be regular red. Also, this 9 and 5 are this gray right here. Because this goes over here, and this goes over here, so the rest, the 14, comes from that 4 and 5. Oh, here's something I realized. There's nothing you can do that equals 14. Like, if you have a, you can't have a 9 in a 4-cell 14 cage. Because the sum of these is 14. If one of them was 9, the minimum the other 3 could be is 1, 2, 3, which equals 6. That would make 15. So 9 can't be in here. So it's either here or up here. What the freak? Same with over here. Oh, and something else I noticed is 14. There's only one version of 14. Like, only one combination of numbers that add up to 14 contains a 5, and that is, I think 2, 3, 4, 5, right? Yeah. So this is actually, these are both actually, 2, 3, 4, 5s. Which is interesting. That means the sum of this is either 5, 6, 7, 8, or 9. So this is 5, 6, 7, 8, or 9. The minimum is 5 because 2 and 3 are the lowest digits you can do. And the maximum is 9 because 4 and 5 are the highest digits you can do. This, on the other hand, this is interesting. This can't be a 2. You can't have 2 here that add up to 2. It can't be a 3 if this is 1 and 2. We can put 1 and 2 in there. If it's a 4, it has to be 1 and 3. And if it's a 5, it can be 1, 4, or 2, 3. So this is a 1, 2, 3, 4 pair. Or, not pair, but you know what I mean. Right, and the same thing is true over here. This is 5, 6, 7, 8, or 9. And these are 1, 2, 3, 4. So the minimum this can be right here is 3 plus 5, 8. So yeah, if this is 1, 2, 3 right here, which it would have to be 1 and 3 and 2, or 3 would have to be there. Or what am I talking about? Okay, ignore that. If there's a 1, 2, 3, the minimum it can be, that's 6 plus 5, 11. So the minimum this can be is 11. And then if this is 9 and 8, and 3 and 4, that's 24 as a maximum. So it's 11 or 24. That's pretty goofy. Oh wait, I think I just remembered how I discovered something. So this and this are right here, and this and this are here. So those are all the same sum. This sum is the same as this sum, which means the remaining sums right here are the same. So let's add a new color. Let's make it peach. That suggests that those are the same. We can do the same thing here. Let's do brown. Brown would be the same as that. But unlike what we said before, we don't know if this has the same sum as this. If this is a 3, this is 1, 2. This is either 2, 4, 2, 5, or 4, 5. So it's either 6, 7, or 9. Oh wait, you know what? I know what these are. These are 2, 3, 4, and 5. So I could probably figure out which version of reality this is. It's meant to equal 16. Right? Was it? This is 16, 32, plus 8. That makes 40 plus 5, 45. Yeah, so this is supposed to be 8. Which means this is supposed to be 16. So they can't have a 2, a 3, a 4, or a 5. The only options left are 1, 6, 9 or 1, 7, 8. And if it's 1, 6, 9, then that takes out the 1 and the 6 from here, making 2, 7, which would make 9, not 8. So it can't be 1, 6, 9. It'd have to be 1, 7, 8. Which means this doesn't have a 9. But wouldn't the same thing be true over here? Wouldn't this also be 1, 7, 8? Knocking 7 out of both of these. Did I make a mistake? So if this is the same as this is the same as this, then this would be the same as this. And since this equals 14, this must equal 14. 5 has to be in one of these. So it must be a 14 cell that contains 5, and I was wrong earlier. There's another option that also contains 5. So we can delete all of this. There's an option that contains 5. And that option is 1, 2, 5, 6. So our options are 1, 2, 5, 6 or 2, 3, 4, 5. So both of those options have 2 and 5. So we know that there's a 2 in here as well. And also these shouldn't be in those kind of numbers. They should be in those. 2 or 5. So we can say that that shouldn't be big either. That should be small. We can't say that this can't have a 2 or a 5. So we need 16. So this is either 1, 7, 8 or 3, 4, 9. If it's 1, 7, 8, then this is 6, 9. If it's 3, 4, 9, then this is 7, 8. I'm going to say something kind of wild. And that requires me removing the color from these. There's 45, a sum of 45 here, and a sum of 45 here. If we remove this from both, then these still have the same sum. So this sum is the same as this sum. But I think we established earlier that this sum is different than this sum. We know that this sum is the same as this sum, which means we know that this sum is the same as this sum. That's new information, I think. I don't know if it's helpful or not. I would make them different. Okay, so these both add up to 14. But if they both add up to 14, there's two ways for them to add up to 14. So, one of the ways, if both of them were one of the ways, it would make the digits in these three be the same. And if the digits in those three are the same, for instance, let's look like what we were looking at earlier. If this is 2, 3, 4, 5, then this is 1, 7, 8, and this is 1, 7, 8, knocking 7 out of both of these. Yeah? So they can't both be 2, 3, 4, 5. Okay, and then the other option was 1, 2, 5, 6. And if they're both 1, 2, 5, 6, then these would both be 3, 4, 9. And they can both be 3, 4, 9. If they're both 3, 4, 9, these are both 7, 8, which is fine. Okay. But if this is... Okay, I think I'm seeing it. If this is 2, 3, 4, 5, then this is 1, 7, 8. Let's put that in. 1, 7, 8. Knocking 7 and 1 out of here. And making this 6, 9. Making this 7, 8. Making this 7, 8. Making this 6, 9. Or, I did that wrong. 6, 9. Okay. And we know that if we make this 2, 3, 4, 5, it would make this 1, 7, 8. And it would knock 7 out of there, as well as 1. And we can't do that, so this would have to be 1, 2, 5, 6. And if it's 1, 2, 5, 6, it can't be 1, 2, 5, 6. Because there's a 6 right there. So that means this can't be 2, 3, 4, 5. And this can't be 2, 3, 4, 5. They both have to be 1, 2, 5, 6. These are both 1, 2, 5, 6. So we can get rid of these 2 and 5 pencil mark. Which means these are both, if I remember correctly, it's 3, 4, 9, right? Yeah. These are both 3, 4, 9. Meaning these can't be 6, 9. Oh. Meaning that knocks 7 and 8 out of here. Okay, this has a minimum of 3. It can be 6. It can be 7. It can be 8. And that's it. And this can't be 1 because you can't add 2 things to make 1, and it can't be 2 because 2 would need double 1 and you can't have 2 1s in the same box. So this is 5 or 6, meaning this can be 1, 4, 2, 3, 1, 5, or 2, 4. So 1, 2, 3, 4, 5. Right, and if this is 3, 4, 9, then this is 8 paired with the 2 that made 8 that we didn't use. So it's either 1, 7 or 2, 6. 8 and 1, 7 or 2, 6. We know it has 8. Which means we know that this is not 8. Let me just put the same pencil marks down here. We know that 1 and 2. Oh yeah, you cannot be a 1 or 2. We know that 1 and 2 are in those spots. We know that 3 and 4 are down here. Actually, we know that 3, 4, and 9. Actually, oh yeah. 9 is up here, 9 is right there. So 9 is here. And the same thing, 9 is here. Which means these are the same digit. 7 and 8 are in this area. Nine is in this area. This is 2, 6, 8. This can't have a 2. This can't be 6. If this can't have a 2, then it also doesn't have a 3. Because the only thing 3 can go with to make something is 2. This would become either 1, 4 or 1, 5. This wouldn't be a 6. So this would either be 1, 2 to make 3 or 1, 6 to make 7. So if this is 2, 6, 8, then there's a 1 on here and a 1 on here. That puts a 4 down here. If this is 1, 7, 8, this can't have a 1, so that means it would also not be able to have a 5, which would mean there'd be a 5 over here. So in one world, there's a 3 over here, and in another world, there's a 5 over here. I mean, not 3, 4. If this doesn't have a 7, this can't have a 6. It can't be 2, 5. Or 2. It would have to be 1, 2 or 1, 6. In both scenarios, one of these has to be a 1, which means that is not a 1. 1 is in one of those places. And we can say the same thing about over here. So in one world, one of these is a 4, and in another world, one of these is a 5. Can it be a 4 and a 5? If it's a 4 and a 5, then this equals 18. This is 15, 4, so it can't be a 4 and a 5. So there is a 4 or a 5 on here. So this is never 2, 3. In that case, 3 can't be on here. Which means 3 is in one of these places. And I suppose we can put all this information in here. One of these. So 3. These are either a 4 or a 5. Or I guess if one of these is a 3. If one of these is a 3, that means the other one is 5. Which means this is a 2. This is a 6. This is a 1, 5. So this is a 6. So if one of these is a 3, then the other one has to be a 5. If one of these is a 3, one of them can't be a 4, because if they're a 4, this equals 7. We get that to this, that's 16. And this is the same sum. We know this is 15, so we would have to add a 1 there, and we can't do that. So one of these wouldn't be able to be 4. So the other one would be 5. So this is what happens just if this isn't a 3. If this isn't a 3, then it's a 6. I think I'm gonna write one possibility over here and the other one over here, and then fill in the pencil marks, because I know both of them are going to happen. I just don't know which one goes on which side until I figure out what that digit is. If this is 1, seven, 8, there's not a 1 here. There's not a 7 here. This can't have a 5. So that'll be 2, 4. So these wouldn't have 4. They would be 3, 5. Okay, and if it's 2, 6, 8, then these don't have 2. This isn't a 6. So this is 1, 2. This isn't 2. Oh, this wouldn't have a 3. So it would have a 7. So now we can add, this is 3, 5, 4, or 7. That's interesting. If this is a 7, that means this is a 7. That takes 7 out of this and this, making both of them 2, 6, 8. Taking 2 out of this and this, meaning there's nowhere for 2 to go in here. So this can't be a 7, and this can't be a 7. Hold on, I'm gonna go back to the version of reality where it's 7. We'll say this is a 7. Well, one of these is, never mind. We'll say this is 7. We'll say... Wait, I don't want to put it in big text. We'll say that it's a 7 and that this is a 5. This is 7, this is 5. There's not a 7 up here, which means there's not a 1 up here. There's not a 5 in here. This becomes a 6, which means there's not a 1 in here. And that means there's nowhere for a 1. Hold on, let me just do all of that again. If this is 178 and this is 268, this doesn't have a 7, these don't have 1. This would be 2, so those are both 6 in this world. That's cool. And then this is 268. Those don't have 2. This doesn't have 6. So that's not a 5. This isn't a 2. If this is 3, 5, then that needs a 2 right there, so it can't have 3 or 5. So this is a 4. This is a 7. This doesn't have 4. So this becomes a 6, and this becomes a 5. So we have a 6, and in this world, those are both 6. These are 6. These have 1. These have 1 or 2. Oh wait, no, I can do better than that. Oh, there's 5 here, so this would make this a 1. This a 5. Making this a 2, and this a 1. So, this is 2 or 5. This is 1. This is 2 or 5. So that's a 6, which means this isn't a 6. Which means this isn't a 2. And this 1 means this isn't a 1. Which means this isn't a 7. This 1 and 6 means that these don't have 1 or 6, which means these don't have 2. This doesn't have 2 or a 7. So we have a 1 6 pair here and a 2 7 pair here. Wait. What if this is 3? Then this is 3. And those are both 5. This is 5, and this is 5, and those are both 3. If this is 4, then this is 4, and those are both 7. Meaning all of this would be the same. Did I do something wrong? Hold on, let me start from the beginning. this is 2, 6, 8. These have 1, 2, 5, and 6. These have 1, 3, 4, 5, 7, and 9. How did I deduce this? Oh, yeah, 9. 9 can't be over here. Nine can't be there. There's no way you could add these to make 9. So 9's not there. So this is a 9. That can't be 1. It's either 3. It can't be 4. Okay, this can't be 1 or 2. This can't have 7. This has to have 1. If it doesn't, then the minimum is going to be a 7. And 7 isn't an option. So this has to have 1, which means these can't have 1. You can't add 3 with anything here to make 5 or 6. You'd either have to do 3, 2. There's no 2. Or 3, 3. And you can't do double 3, so this can't have 3. So this is 1, 4 or 1, 5. So 5 is either here, here, or here, and this digit sees all 3 of those. But both of these digits see all 3 of those, so 5 can't be over here. If this is a 5, then this is a 5. There's no way to make 5 using these digits. We would need either 2, 3, or 1, 4. We don't have 3 or 4 here, so this can't be a 5. So this is either 1, 2, 2, 5, or 1, 6. This has a 5, which means it doesn't have a 4. This is a 1, 5. And this is a 6. So these don't have 6. So this is either 1, 2, or 2, 5. So it does have a 2. This is a 1, 5 pair, meaning this doesn't have a 1 or 5. It is a 2. So this doesn't have a 2. This is a 1, 5 pair. There is a 4 down here. If 4 goes with 3, that makes 7, making this 16. And that means this would be 16. This has 15, and there's a 1 there. So that works. This would be 1, this would be 5. This would be 1, this would be 5, this would be 7. Okay. If this is 4, 7, then this is 11. Add the 9, that's 20. So this is 20, there's 15 here, so this whole thing would be 20. This would be 5, this would be 1, this would be 2, this would be 3. Huh. Okay, I think I did make a mistake earlier. Because this is not the result I had earlier. Okay, let's do the same thing for over here then. But for the other set, this will be 1, 7, 8. This is still 1, 2, 5, 6. And this is 2, 3, 4, 5, 6, 9. This makes it so these can't be 9. This can't be a 9. And there's no way to add up these digits that makes a 9, so that can't be a 9. So the only spot left is right here, meaning that these are the same digit. So this would be 3, 4, or 7. It can't be a 7. So that's not a 7. Okay. This can't be 2. This can't be 1 or 2. This can't have 6 or 5. This is either 2, 3, or 2, 4, so it does have a 2, so that's not a 2. These don't have 6. There's no way to add these up to make 4. There's no way to add these up to make 5. This is either 1, 2, or 1, 5. So there is a 1 on it, meaning this is not a 1. This is a 2, 3, 4 pair, meaning this is not a 3 or a 4. This is a 5, 6 pair, meaning this is not a 5. Oh, this is not a 3, which means this is not a 6. This would have to be like that. So this is not a 5. This is not a 5. This would be like that. This is not a 2. This is not a 4. So if this is a 4, and this is a 5, actually I should say this is 17. So this actually, this is not a 6. It's a 5. And this is a 3, meaning this is 3. I mean, yeah, this is a 3. Meaning this is not a 3. It is a 4. Because there has to be a 4 in this box. So this is not a 3, it's a 7. So this is a 5. This is a 1. This is a 5. This is a 1. And let's see, this is 7 plus 9 is 16. 15, 16, okay. This is 8 plus 9, that's 17. 15, 17. Okay, so this is how it really goes, with these being the same and these being different. So let's fill everything back in because we don't know which way around this goes. This is a 1 or a 2. This is a 1 or a 5. This is a 2 or a 5. This is still a 6. This is a 1 or a 2. This is a 6 or a 7. This is a 4 or a 5. This is a 4 or a 5. And this is a 3. And now we know what this is. This is 12. Okay. 12. 12 always has like 12 in a 4 cell. 4 digits adding up to 12. 4 different digits adding up to 12 always have 1 and 2. It's either 1, 2, 3, 6 or 1, 2, 4, 5. Something I can tell you is that 4 and 5 are in one of those 4 spots in box 9. Oh, this can still have a 1, which means this can still have a 7. And this can still have a 1, and this can still have a 7. Except for this can't be a 3. And this can't be a 3, meaning that this is a 3. Now we got a little 4-8 pair right here. Oh, and I should fill these back in. 1, 7, 2, 6. Actually, that's interesting. So this is either 1, 2, 3, 6 or 1, 2, 4, 5. It can't have 3. 3 sees all of it, so it's gotta be 1, 2, 4, 5. So let's get rid of those and put 1, 2, 4, 5. We know that 3 is in here. And the rest will be, we got 3, 9, 6, 7, 8. Where that's not a 3 or a 9. It's certainly not a 5, like I suggested before. So the minimum this can be is 9, 16. The minimum this can be is 16. And the maximum this can be is 17. So I guess what I should do is ask if this can have a 9 on it. If this is 9, it's paired with a 3 and a 6 at minimum. So that's 18. We can't make 18 in a 2 cell because that would need 2 9s. So this cannot have 9 on it. Which means the only spot left for 9 to be is right here. Okay. If this is 8, the minimum it can have with it are 3 and 6. That would be 3. That'd be 17. So that's fine. There is a 3 on this. What would it look like if there's not a 6 on it? It would be 3, 7, 8. That would be 18. That's not possible, so there has to be a 6 on here. Which means this can't have a 6. This is 7 or 8. So this is either 12, 15, 16, or 17. Up here. The minimum this can now be is 12. Oh. These can't have 4 or 5, which means these can't have 1 or 2. Because that 4 and 5 and that 4 and 5 saw these spots. And then that was a 1, 2 pair, so get 1 and 2 out of those spots. There's a 9 in one of those 3 spots, and there's a 9 in one of those 3 spots. Here's an interesting thing. These are different. And they both see that cell, which means that is not a 1 or a 2. These are different and also both see those cells, so that's not a 5. What can this cell be? It can be a 3, a 4, and that's it. It can be a 3, a 4, a 7, or an 8. This can't be a 2 or a 5. Because these are different and they both see this cell. This is less restricted. It can be a 1, a 3, a 4, a 1, a 3, a 4, a 1, a 3, a 4, a 7, or an 8. Because this is not that much less restricted. If you don't have a 1, that's fine, because this can be 7, 8, 2. What can you be? 1, 2, 3, 4, 5. Can't be 6, 7, 8, or 9 though. Does it see 6 right here, a 7 and 8 here, 9 here. It also sees 6 here. This is the same. Sees 1. It can be 1, 2, 3, 4, 5. It can't be 6, 7, 8, or 9. Oh, there's a 1. There's a 1 in one of those places. And in one of those places. So 1 can't be here or here. So this is 2, 3, 4, 5, 7, or 8. I don't like that pencil mark. This is 1, 2, 3, 4, or 5. Oh, this is here. These are the same, and these are the same. I'm gonna get rid of the red. I don't think the red is needed anymore. Oh, right. I don't think that really helped. Except for this. Actually, maybe. Pink. Pink has to go in this box. Which means pink is over here. Which means pink is up here. One of these is pink. Which means one of those is pink. Blue is over here. So one of these is blue. Which means one of these is blue. And since pink and blue are 7 and 8, one of those here, one of those here, that means 7 is in one of those places, and 8 is in one of those places, meaning 7 is not up here. and that means 1 is not right there. Wait, these could both be 8. So none of that's true. For a second I thought this was a 7-8 pair for some reason. So if this was a 7, this would be a 7, and this would be a 7, but that's not true. If this is a 7, this could still be a 7. These could both be 8. This is either 3, 6, 7 or 3, 6, 8. Which means it's either 16 or 17. 16 in 2 cells. 16 in 2 cells is 7, 9. And 17 in 2 cells is 8, 9, which means these both contain 9. Like, whichever way it is, they have to contain 9. So that means that these are both 9. And these are not 9. Oh. So 16 or 17, which means these are 7 or 8. Which means these are the same. These are the same. And these see all of those, which means green has to be right here, which means this cell is 7 or 8. Okay, if this is 7, that means that this is 17, which means that this is 8. So if this is 7, this is 8. So that means that this is different than these. These are different. So this is in one of these spots. So we know that this is different than this, and that these are the same as this. One of these is over here, and one of them is up here. This one is in here. That's interesting. There's a 7 or 8 in here that goes up here, and this 7 or 8 must go in this box, and it can't be in one of those spots, so it's up here. So let's just make this that color, so it will appear in one of those spots, and also in one of those spots, and this is yellow, so this goes right here, so the rest of them have to add up to 9. So it's a 7 and an 8, and the other 3 add up to 9. That's interesting, but I guess that means there is a 7 or an 8. Oh, that is interesting. There's a 7 or an 8 in one of those positions, and there's a 7 or an 8 in one of those positions, which means there's a 7 or an 8 here and a 7 or 8 here, which means in this column both 7 and 8 are used, so that means this can't be a 7 or an 8. And in this row both 7 and 8 are used, so this can't be a 7 or an 8, which means the only places for 7 or 8 to go in this box are here and here, so this is not a 1, a 3, a 4, it's not a 1, a 3, or a 4, so this is a 7, 8 pair, meaning that this is 15, the maximum it can be is 17. So this can only be a 1 or a 2. And this, it's a 16 or a 17. Which means this is a 7 or an 8. This is the green 7 or 8. And we have both 7s and 8s in this box, so these can't be 7 or 8. This is a 3-6 pair, so we can get rid of this 3-6 and this 3-6. Whew. Okay. Oh, so there's a green 7 or 8 here, and there's a green 7 or 8 here, which means the green 7 or 8 has to go there, which means this is not a 1, a 2, or a 6. It is, in fact, the green 7 or 8. And let's change the color of this to not get confused. Let's make it that color. Actually, we don't even need that anymore. We already have that marked. Let's just make it, let's make this one, let's make this one that and that, so that we can remember that these are the same as these. Okay, and then I think the same is true the other way around. But yeah, there's a green 7 or 8 here, and there's a green 7 or 8 here. So there must be one in this box. The only place for it is right here. So this cannot be a 1, a 2, or a 6. It is the green 7 or 8. Which is the same. That is interesting. So these equal the same thing. Oh, and they can't both be 7, because that would break these 7s. So these are both 8. So we can get rid of, so all green is 8. Which means all of these are 7. These don't have 7. No. These don't have 7. These don't have 7. So those are... Okay, so I made a mistake. And all red ones are 7. So there's a 7 in one of those and a 7 in one of those. That's what I got wrong before. I got confused and I put 8s here. So we can get rid of the green and red coloring now. But these have 1, 2, 3, 4, and 5. This is a 1 or a 2. This is what's going to disambiguate everything. So this is 12. You can't have 9, 8, or 7, or 3. So it's either 1, 5, 6, or 2, 4, 6. And it always has a 6. The same is true over here. So it's 1, 5, 6, or 2, 4, 6. 1, 5, 6, or 2, 4, 6. So this is either 1, 3, 5, 7, or 2, 3, 4, 7. So it always has a 3. This always has a 3. These are... Oh, that's not what I meant to do. These are 1, 3, 5, 7, or 2, 3, 4, 7. And these can't have 7. This can't be a 6. This can't be a 6. We have 1, 2, 3, 4. Oh, this can't be a 9. And this can't be a 9. These can't have 8. And these can't have 8. Oh! We know what this equals. This is 17, which means this is 2. And these all don't have 2. And this doesn't have a 2. Oh, and this doesn't have a 2. Which means it's a 5. Which means this is a 1. Which means this is a 2. And this is a 2. This is a 6. Oh. We know those don't have 4. We know those don't have 4 or 5. Oh, we also know those don't have 4 or 5. That's a 6, so this is a 4, and this is a 5. And this doesn't have 2, which means it doesn't have 6, which means this doesn't have 1 or 7, which means this is a 2, which means this is a 6, which means these don't have 2. These don't have 2 or 6, that's 1, 7, so these don't have 1 or 7, which means this is a 7, which means this is a 5, this is a 2, this is a 1, this is a 4, this is a 5, this is a 1, so these don't have 1 or 7, this isn't a 2, these don't have 1 or 5, these don't have 1 or 2, this isn't a 5, these don't have, this isn't a, this is a 3, so this is a 6, this is a 7, that's not a 7, this isn't a 2, oh, this isn't a 3, which means we have a 1, 2 pair here, so that's not a 2, it's a 6, so this is a 2, so this isn't a 2, that's not a 3. Oh, 1 is in one of those spots. So this isn't a 1, it's a 2. So this is a 1. This isn't a 2. 1 is in one of these spots. So 1 is right here. So this is a 2. This isn't a 1. Oh, this isn't a 1, which means in this row, the only place the 1 can be is right here. So this isn't a 1. This is a 4-5 pair right here. So these can't be 4 or 5. This isn't a 1, so it's a 6. This is a 2. This has to equal 12. So this is a 4. And this is a 5. These don't have 4. This is a 4. So these don't have 4. It's a 5-6 pair. So we can get rid of that 6 pencil mark. But we now know that this can't have 5. So it's a 3-4 pair, and we can get rid of that 3 pencil mark. We need 5 in this box, and the only place it can go is right here. Which means this isn't a 5. We can get rid of these pencil marks since we know... Oh, actually, this... We need 1 in this box, and the only place it can go is here. There's a 2 here, so that's not a 2. So this is a 3-7 pair. We can get rid of the pencil marks. And since there's a 3 here, there's not a 3 here, so that's a 4. So that's a 3. That's a 5. That's a 3. These don't have 3. That's not a 4. That's a 9. That's a 4. Oh, this 1 sees that, so the 1's here. And this is a 7. This 4 sees that, so it's a 3. These don't have 3. This 1 sees that, so it's a 7. This is a 1. This 7 sees this, so it's a 3. This is a 7. This 7 sees that, so it's a 7. This is an 8, which means this is a 4. This is an 8. This is a 7. This is an 8. This 3 sees this, so it's a 4. And this is a 3. This 4 sees this, so it's a 9. And this is a 4. This 5 sees this, so it's a 6. And this is a 5. And this 6 sees that, so it's a 9. And this is a 6. I did it! It only took me that much time. I don't even know how long that is, but many hours, I presume. I'm so sorry you had to sit through me trying to get through the break-in, even. Took me ages to get in the break-in. But that was a great puzzle. Very tricky for someone who doesn't have math in their head. I hope you liked it. If you want to see more videos like this, I've got a bunch on my channel. Most of them are Marty Sears Rat Run series, but I also do other puzzles as well. So I'll probably leave a link to like the end screen. I'll put a video for you guys to go watch, so you better click that, buddy. Anyways, only one more thing I gotta say is stay cozy.